We have learned that the tangent ratio is the ratio of the opposite side to the adjacent side in a right triangle. Okay, so we've learned that ratio. Today, we're going to talk about the other two. We are going to talk about sine and cosine, and we're going to go over when and why we pick sine, cosine, or tangent. Before we go into that, quick reminder because we still need to be able to label our triangle correctly, how to label the sides of a right triangle. Remember, we have opposite, adjacent, and hypotenuse. First thing, label the hypotenuse. It is always the side across from the right angle. It's also the longest. Step 2, place your binoculars or your eyeballs at the angle theta that you know or are trying to find. Then we're going to label the opposite side. This is the side opposite of the angle theta. Look through those binoculars. And then your adjacent side is the side next to the angle theta. This is the one that's last there and has legs of the angle. So now that we have our sides labeled with our angle theta that we know, and again, remember they change depending on where that angle theta is, we can talk about our three trig ratios. The tangent ratio, it's the ratio of the opposite side to the adjacent side. Okay, the sine ratio is the ratio of the opposite side to the hypotenuse. And the cosine ratio is going to be the ratio of the adjacent side to the hypotenuse. And guess what? We have a fun way to remember that. So don't worry about trying to memorize it. SohCahToa. SohCahToa, SohCahToa, SohCahToa is an easy way to remember trig ratios. The word SohCahToa helps remember the definitions of sine, cosine, and tangent. Here is how it works. Okay, the first one, the acronym part, SO. The verbal description of that is sine is opposite over hypotenuse. Sine of angle A is opposite over hypotenuse. Sine OH. So cosine, adjacent over hypotenuse. So cosine of angle A, adjacent over hypotenuse, C-A-H, ka. Toa, tangent is opposite over adjacent. So toa, tangent, opposite over adjacent. So sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. If you remember SohCahToa, you can remember which ones go with which. Also, you can use your notes. SohCahToa. And I do want to go through the steps one more time for finding an unknown side of a right triangle using trig. Same steps as we listed when solving using tangent. This time in step 2, remember when we were doing tangent, I said all these problems are going to be tangent. So disregard so and ka, but this time we have to choose. So that's a key one, step 2, determining which trig ratio to use. So step 1, label the side. Step 2, determine which trig ratio to use. Step 3, create your equation, write it down. Step 4, use a calculator because you have to, desmos.com, and solve. And I actually put in here, if unknown is in the numerator, so in the top, the x is in the top, there's an example of how you solve that. You just multiply by the denominator and then solve. If unknown is in the denominator, if the x is in the denominator, a little bit harder, you have to multiply both sides by x and then solve. So those are just some examples similar to ones we've done before or that we are going to do that might come up. So save that in your notes. It's in there just as your help. So we use these steps to solve some problems next. It does go through our trigonometry, tangent, sine, and cosine. Just a note here, tangent, ratio of opposite over adjacent. The abbreviation for tangent is just tan. So that's why tangent looks like tan here. Sine, the abbreviation is sin. Takes the E off. Cut it a little short, I guess. And then cosine, the abbreviation is cos. So if you ever see those, they mean the same thing. It's just the abbreviation. Same thing here. Hyp stands for hypotenuse. Op stands for opposite. And ADJ, it stands for adjacent. So I want to go through those really quick. Your steps also are always here if you need them. And we're going to go through a few problems together. Make this a little bit bigger. All right, so it looks like we just have two quick problems. So wants you to find the sine of D, sine of F, cosine of D, cosine of F. Write each answer as a fraction and as a decimal rounded to 4 places. Fun. Okay, so let's start with D. So let's just solve the problems that we're dealing with angle D, because again, how you label your triangle is based off of the angle we're looking at. So we're going to do these ones first with the D. So this is our angle D. This is where my eyeballs are going to go. Okay, so this is a right triangle. Our 90-degree angle is right here. Across from our 90-degree angle, our longest side, again, that is our hypotenuse. Let's just keep that in blue, I guess, here. Hypotenuse. Opposites across from our eyeballs, shoot an arrow, hit. This was going to be our opposite side. And then process of elimination, or sharing an angle with that side, is our adjacent. All right, so I'm going to go ahead. I think I'm just going to copy paste from up here to make it a little bit easier. I'm just going to copy this and bring it down here so we can have it handy. SohCahToa, SohCahToa, SohCahToa. Oh no, that is not what I wanted. Got it all grouped, huh? No, paste it. There we go. Bloop. All right, that will help us out. SohCahToa. Okay. Sine of angle D. Sine is the ratio of the opposite over the hypotenuse. So sine of angle D is the ratio of opposite, which is 7, over hypotenuse, which is 25. That actually cannot be reduced. 7 over 25. Pop that into Desmos. 0.28. Cosine of angle D, we're still looking at angle D. Cosine is the ratio of adjacent over hypotenuse. So the adjacent is 24. I'm going to change, oops, didn't want that. 24 over hypotenuse, 25. Again, can't reduce that. 24 divided by 25. 0.96. Oops, I even put that in the wrong spot, didn't I? 24 over 25 and 0.96. I'm going to change colors so that I don't look like I'm like overlapping here. Okay, that's for angle D. Okay, next we want to do angle F. So I'm going to go ahead and I'm going to keep my hypotenuse the same here because that one doesn't change, but my eyeballs are going to change to a different location. We're going to change them to angle F. And so our opposite and our adjacent are going to flip-flop. So where's angle F? Right here. That's where my eyeballs are going to go. So my opposite is now here, and my adjacent is the 7. So sine of angle F, sine opposite over hypotenuse. So opposite is 24, hypotenuse is 25. Is going to be that one, and then we know that one's 0.96. Okay, you can kind of see a pattern here. Cosine of angle F, cosine is adjacent over hypotenuse. So adjacent is 7, hypotenuse is 25, 7 over 25. That pattern, 0.28. What do you notice that happens? What do you compare about the two of those when you flip-flop them like that? That's all you had to do on that one. We weren't doing any solving. This one we are. So we're going to go through our steps up here. So label, determine, all those things. And okay, so find the values of u and t using sine and cosine. Deep breaths. We can do this, right? All right. First step, label the sides of your triangle. So, okay, let's find u first. Let's not even worry about t. Let's just worry about u. Okay, so because there's a couple ways we could actually do this. We're going to put our eyeballs here at the angle we know, 65 degrees. Eyeballs here. So label our triangle. Crossing the 90 is our hypotenuse. So this is my hypotenuse, the 8. Opposite the angle we know is my opposite side. And then my adjacent side is the u here. All right. So Let's find angle U. So what do we know? So when we're trying to determine, so that's our, what step was that? Step 3. 2. Determine which trig ratio. How you determine which trig ratio you use is you figure out what do we know and what are we trying to find. Okay, so in this case, we know the hypotenuse. I'm going to do a highlight. We know the hypotenuse. What are we trying to find? Well, we're working on U in this case. To find U, we want to find the adjacent. So that's going to tell us what trig ratio we're going to use. We're going to use the trig ratio that deals with adjacent and hypotenuse. So which trig ratio, I thought I just have that right there, deals with adjacent and hypotenuse. Adjacent, hypotenuse, cosine. Okay. I also think sometimes we don't care about the opposite. So which one has to do with opposite? These ones. So we don't care about those. We want adjacent and hypotenuse. So not cosine. So that's your step then, is to write the equation. So cosine theta equals adjacent over hypotenuse. Okay. Cosine theta. What is our theta? Theta is the angle we know, 65, equals adjacent, which is U, over hypotenuse, which is 8. Okay, we're going to solve this. Remember, if the number's on the bottom, it's a little bit easier. To get rid of that 8, we multiply both sides by that 8. So our answer is just 8 times the cosine of 65. Go back to our Desmos. 8 times cosine 65. 3.38. It's you see how the squiggly lines, those mean approximate. So U is approximately 3.38. 3.38. Okay, from here is a few ways we could go. We could actually just do Pythagorean theorem. 3.38 squared plus t squared equals 8 squared. Solve it for t. That is taking a rounded number and, going through and rounding it even more. So not going to give you the most accurate answer, but it works. But let's just, because I want to, keep working on these types of problems where we are, solving using trig, I want to go through it using trig. So next we are going to find t, side t. So I'm just going to pretend we don't even know U. I don't know U yet. I'm not going to have it there. All right, so to find t, this time I'm going to highlight what we want to find. We want to find the t, which is opposite. And again, we're going to highlight what we know. And even if we did put in that we knew adjacent was 3.38, that's not one we would say we technically know. We found it, and it's a rounded answer, and so we're not really going to use it. We're going to use this one that we know here. This is that 8. It's a whole number. It's not rounded. It's going to be a lot easier. So opposite and hypotenuse, that is sine. Color change right there. That's cool. And so we are going to set up our equation for sine. So sine theta equals opposite over hypotenuse. Okay, so plug that in. Sine of theta, theta is the angle we know. It's still 65, nothing changed there. Equals opposite, which was t. That's a t. It's like a weird t. Divided by hypotenuse, 8. Look at that. This one's another nice easy one. You multiply both sides by 8. 8 times the sine of 65. Just delete this here. How nice that was. 8 times sine 65. Let's see if that worked the same. 8 times sine 65. Yeah. 7.25. That's again a t. It's kind of like weird F, right? I don't know why I write my t's like that. 7.25 My answer there. Just for a challenge, one more thing you could do, just a reminder that the sum of the angles of a triangle is 180. So we could have done 90 minus 65 is 25. We could have labeled the fact that this angle here is 25 degrees, and we actually could have used that as my eyeballs, and then this would have been opposite, this would have been hypotenuse, this would have been adjacent, and I'll bet you get the same answers. So maybe give it a try if you want. And again, this stuff's tricky, so be sure and reach out if you're stuck or needing help or want to go through some more problems together.